Alright, here's the wireless transmission. And right now I've reconfigured the primary a little bit. Just added two and two twos in parallel. And it keeps the heat down dramatically. I don't know, I just have it set up a little funny way here with the diodes, germanium diodes, kind of going off of one of the other green wire. It helps to reduce the milliamp usage at any rate. Have a little 6 volt, 1.2 amp hour lead acid battery. And is sitting about 644, 643 volts right now. So we have the milliamp. We're going to test the milliamp usage off of this coil. These are 5.5 volt, 1 farad capacitors, super caps. And these are all, secondaries. The receiving coils are set up to transmit also, because if you take the transistor out, they don't really work. They do, but it works at a much reduced efficiency. So we have in here, of course, just a simple little inductor to tell me that the system's working. It'll light the LED. And these are what the circuits kind of look like here. On the bottom of the secondary coils are just connected to the base of the transistors. The tops of the wires are dangling. And of course, this one's not really attached at all. It's just sitting so it conducts into the aluminum ball. You want an aluminum ball, just ball up some tin foil, kind of make it as round as you can, and that's sufficient, because the bigger you get, the more capacitance it adds to the system. It drops the frequency and it dissipates a lot more energy. So you start using in the hundreds of milliamps. The system should use under 200 milliamps. We have a little non-contact voltage detector here. So let me go ahead and start this up. See, the light came on, the little LED. Using 31, 36, 38 milliamps, 40 milliamps. There we go. Using 165.5 milliamps. Now it's funny because once these capacitors get loaded, then it uses less milliamps. Now, see, we're using 27 milliamps. Battery voltage 6.18. 172 milliamps. Now we're going to see what the frequency of the system is. .24 something megahertz. 1.254 megahertz. Using 24, almost 25 milliamps. That little battery is. Input 172 milliamps. Okay. And there's no connection at all to anything else. Now apparently I'm inducting a lot more right here. I think the battery is probably, the capacitor is probably over voltage by now. So I've disconnected the battery. Now we're just using the stored energy. So I'm receiving a lot more energy than I'm using. And the capacitor stores that. So this little, as the voltage drops, it's probably about 3 volt now. That motor starts up about 2.6 volts or so. But I'm still using that much milliamps. At probably around 3 volts. That's 21.5 milliamps. Apparently when I have the meter hooked up to this, it's inducting more from the transmitter because this is definitely receiving more energy than this. When the meter's not connected here, I'll show you in a minute, that it's more distributed equally. Still using 15 milliamps. It's probably about 2.5 volts now. Done. Interesting. Okay. So let's see here. Let's see if we can just disconnect this real quick. Reconnect it back. And show you real quick in the same video. That immediately it starts up. And of course, again, these are not connected in any way whatsoever. See if I can get this started. This is a little non-contact voltage meter. There we go. $166 milliamps. You hear the motors getting faster? Or at least the one on the right's getting faster. The one on the left uses a consistent. And here's a fluorescent real quick. You can get it quite high, 6 inches or so. $167 milliamp. Now we're going to disconnect. So you store the energy that's transmitted. And we'll end this at 10 minutes. And we still have power left.